Hi, good morning and hello to all the wonderful people of the eLTER site. This is Diego García Díaz from the Estación Biológica de Doña Ana, CSIC, where I work with Ricardo Díaz Delgado in Work Package 4.4. The purpose of this video is to demonstrate the functionality of the Ndvi2Gif Python package, which is one of the 3 Python packages that we have developed as part of our tasks in this Work Package 4.4. Okay, I've made a short presentation to try that you understand what this package does, because it could be difficult to explain with words, especially for me, especially in English. But I think that with this presentation and after that with the demonstration on the Google Colab, you will get the point of this Python package. Okay, so let's move to the presentation. Okay, so Ndvi, excuse me, here better. So Ndvi2Gif scheme model. This is a Python package, or you can consider a software tool designed to process multi-seasonal indices composite. What does mean? Let's going to see it. Okay, so let's assume that we have a full year, in this case 2022, with of Sentinel-2 image or send capturing during this year. We have a new image appearing once every 5 days, so we can estimate around 6 images per month. If we turn to 1 month, okay, this should be exactly the same for the rest of the month, but we will have 6 images in this month. And what we do with this is we are going to calculate the chosen index, the index that we choose. Okay, this could be the 6 Sentinel-2 string, and we are going to calculate you are going to choose one index when you call this Python the class, the main class, and we are going to calculate the index for the whole year, and then we are going to split and we are going to group this index by period of time. We will see this now. Okay, and after that we are going to create a new image it's no more, that's a compendium or a composite of the 6 images, in this case, in this period, based on the statistical value that is taken. For example, you could have the maximum value that the NDVI reached in all the images of January, or the mean, or the median, or the percentile 90 or 95. This is the stat available at this moment. So we are creating composite based on different periods of the year and based on different statistics, okay, and also in different index. By the way, it's very easy that you can run all the index at once, and we will see an example of that later on the data lab. Okay. Okay, so next thing is that we can split. In this case, it will be the image, the compendium for a month. This will be split in the year in 12 periods. But we also have the possibility to split the year in 4 seasons. In this case, this composite or compendium of the index will be taking all the images in 3 months. Okay, so the statistic will be the statistics based on 18 6 strength in 18 Sentinel-2 stem. Okay, in this example with Sentinel, and this will give us a new raster. This creates a raster for NDVI or the EVI or SAVI or whatever index with 4 bands. One of the bands is the statistics for the period. Okay, this will be the sample that we have seen before, splitting the year in 12 seasons. The first one will be January, is the one that we were showing before, and in this case we will have a raster for 2022, but with 12 bands, 1 per each month, based on the statistical value that we have selected. And last choice is splitting the year in periods of 15 days, in this case in 24 seasons. Okay, so we have, in the case of Sentinel-2, 3 images to calculate the statistics of that 3 images, okay, per period. And we will have scored a new raster for 2022 with 24 bands, for period 1 all along until period 24. Okay. Okay. So, okay, this will be an example for 2022, but the dataset that we have available is the Sentinel-2. In this case, we are using level 1. It's reflectivity in the top of the atmosphere. And this dataset is available from 2015. Okay, but we also have added MODIS that start in 2001 and Landsat starting in 1984. Okay, so this is all the period that we have available for you at this point. I don't know if we will add more data set or not, but this is a huge collection of images. We can do that because behind the scene what we are using is Google Earth Engine, and we are collecting to the Google Earth Engine warehouse, which you have a lot of petabytes of data. It's amazing warehouse of satellite and raster imagery. Okay, but it's not also that you have all this time. You also have available the whole globe. Okay, so it's this is kind of a cheesy image, but it's true because we have the world in our hands. Okay, you can go wherever in the world you want, and you can apply this analysis for that area. And you can tell that it's the Danes logo there because thanks to Danes and to Danes Spy specifically, that we are using it in our Python script. So you can apply this analysis to your site just by typing your Danes ID. Okay, so let's see some practical example. But first, let me show you that the main website of in Python of the Ndvi2Gif Python package. So here you have some information about the statistics that are includes the maximum, mean, median, percentile, 1995, the index that we can available to calculate, the data set that we are using with the link to here. This will lead you to the Earth Engine data catalog. Okay, you have here the info. In this case for Landsat, all Landsat it's all together in one single collection called Landsat. Okay. Here more information. You will see later the beautiful color that this gives us. It's something nice to see. And just some uses the sample, but we are going to watch this right now. Okay. And here it's also important if you go to the home page. If you open this link, this will lead you to the GitHub repo of Ndvi2Gif. Okay, you have here the same information. But if you open here the Ndvi2Gif folder, okay, here we have the code, but we also have a couple of the Python notebook sample, and we are going to work with this one, Ndvi2Gif extended version. So what we are going to do is we are going to click on it, and it's going to be open in GitHub. Okay, and now a small trick is you go to the URL. Okay, here in the GitHub, yeah, maybe this was better. Okay, here at the end of the B in GitHub, if you type to collab, okay, github2collab.com, and the rest of the URL, and you press enter, this is going to open the, okay, this is Google Colab, and this is going to open this notebook in a Google Colab environment. What you can do here, first of all, is you can archive a file, save a copy in your Google Drive, for example. Okay, this is creating a copy, and it's open a copy for you in your. So right now this is this is not the URL open in Google Colab. Now you can close the other one. Okay, you can rename it. This is copy. That's it, video copy. Okay, just to change the name. Okay, so we are here in Google Colab. The first thing that we have to do is to install the libraries. Google Colab comes with a lot of libraries installed, but not all the thousands of Python libraries as there are out there. So we are going to install the libraries that we need. The first one is Gmap. Actually, I'm not sure if Gmap is already installed. Okay, no matter what, this is a very quick process. Let's go to pip install Gmap. Gmap is kind of an official Python API to work with Google Earth Engine, and also add all the mapping capabilities that we are going to be working with. If you like to work with satellite imagery with spatial data and you like Python, you should know Gmap, It's the guy who developed this, Qiushen Hu. It's very active people, and he has a lot of tutorial on YouTube, and he's very active in social media, and it's something very good to know for you in case you already doesn't know. Okay, so this is already installed Gmath, and now we are going to install Ndvi2Gif. Okay, this is already installed. I'm going to comment again. Okay, and then press enter. Okay, so now we are going to import the libraries. We are importing Gmap, we are importing EE, it's come from Engine, this is already pre-installed. From Ndvi2Gif, we are importing our main class. It's called Ndvi seasonality. Okay, here we go, and now we are going to load our first Gmap map. Okay, first time you open this in a Google Colab, it's asks you to who you are, is your credential. So you should be logged in Google Engine. This is a very quick process. Just type synat Google Engine. Okay, singing. Okay, this is almost instantaneously. Okay, I close. I assume that you're already signed in Google Engine, and then what you have to do is you have to open this link. We need a token. Okay, with your account. Keep going. Sell your soul to Google, and copy the token. We copy the token. We come back to our notebook, and just Control B and enter. Okay, so here we have our first map. Okay, we have here upper right. I think you're not watching. Oh, you're not watching my. Okay, upper right it should be a tool. Okay, and if you click on the tool, let me see what can I do for that. Okay, so here you have this is the tool. Okay, and if you open, you have something that you can do here, and here is the layer's name, all the layers that we have loaded on the map. Right now, the only layer is OpenStreetMap, that is base map by default. Okay, if we go again to the tool, and we go to this icon, it's a map, change base map. We could, for example, add some wall imagery, insert wall imagery. Okay, and here we have the wall imagery. And now if I go to the layers, now I have this. Okay, layer on. So what can I do here? I can interact with the map. I for example can draw. I select the rectangle tool, and I can go to Andalusia. Feel free to go wherever you want. Okay, and here I'm going to define a new variable called ROI. That is the last drawing I did in the map. Okay, so I have now this geometry to work with. Okay, so in the next cell code, I'm going to create my first Ndvi seasonality. In this case, I'm going to say that you can see how it does. Ndvi seasonality, I define a region of interest. In this case, it's this rectangle. Then I select the satellite. It's modest, but please change it to Sentinel-2 if your area is not too big. And in the key, we select the statistic. Okay, in this case, I'm selecting, for example, the median. And select and split the year in 12 seasons. Okay, the start year in 2017 and end year 2022. Last year is not included, so this will going from 2017 to 2021. Okay, and the index, here is where you select the index. In this case, is the normalized different water index. Okay. Then I select the visualization parameters. This is the raster band that I want to load in the RGB composition. And the values, you know, all this normalized different index goes from -1 to 1. Okay, and water should be in values above 0. Okay, so if you run this with Shift Enter, so now this is going to calculate the normalized different water index for the whole area of Andalusia. This is a, I don't know, maybe 6 or 8 Sentinel-2 extent. and it's mosaicing and calculating the index and getting the, in this case, the median value of all the index per month, because I'm splitting the year in 12 seasons. To see this better, I'm going to clear the geometry. If you click on the garbage, you can see it clear out. Okay, and I'm removing my rectangle. Okay, here you are watching a lot of weird color, but the good thing is that the water, you are watching actually the water is brighter. In this index, water values are the highest values, so I'm watching the water. Why I'm watching different color? Because the water is, this index does not have the same values over the time. So any slide different, it's going to turn in different color visualization when I load on the map to create this RGB composition. Okay, but you are watching the water, and without knowing anything of Andalusia, you can tell right now where are all the dams in Andalusia. Okay, if I apply some transparency here, okay, you could see this is the real water, the water dams in Andalusia. Okay. Okay, we can go to the Mars. You can see the border between the sea and the land. Yeah, sometimes it takes a little bit to render. Sorry. And you can tell there's not much water on the Mars. These are dry years, but anyway, that's because I select to the RGB visualization March, April, and June. We can change this to January, February, and March, for example. Should be more water. If I run this again, now it should be a little bit more water on the Mars. As I said, this has been dry years. By the way, this is calculating, as you remember from the presentation, this is calculating for every year from 2017 to 2021. It's calculating this composite per month, but by default it's lost the last year. So in this case, is right now I'm watching in the map 2021 is the last year that I created. Okay, so if I click here, if I go to the tool, for example, I could select the plotting tool. Okay, this one. I select my raster. If I click, for example, here, this is an area of the Mars where it's flooded depending on the year, but I would say 5 or 6 months per year. If I click here, I should see this logo. Okay, so the values over 0 is when this was flooded. In this case, this was a very, very dry year, so this was only flooded in March, January, February, and March. The rest of the year is what's dry. Okay. As I said, you could have this for the whole planet. I can move to wherever I want. I could go, for example, I like this area in the border of California, Mexico. By the way, if you are going to load different images, I recommended that you create a new map or just restart your map. Okay, if I don't have to log in Google anymore, just one. So I can go here now and I can do this rectangle. I can redefine a ROI. And if I do the same thing that I did before, exactly the same, but only changing the ROI, I have this again. So without knowing anything of this area, I can tell where is the water, and you can only watch. Nice thing, not just the big permanent water, but also the seasonal water. And that was the color I'm saying to you. Not only that there's water, but also that when it was the water there. Okay. Okay, yes, you can apply this to the whole world. Okay, so let me restart the map again, and I come back to Doñana. Okay, redefine my region of interest again, and now I'm going to start to work with vegetation index. In this case, with Ndvi. Okay, so if you look here in the code of this code block. I'm selecting the band names P2, P10, P17. As you can imagine, this is for the 24 splitting season, but I'm saying that I'm splitting the period, the season in 12. So I would change this to the name of the month of the year, otherwise it will throw you an error. So I don't know, I would, for example, January, April, and August. Okay, so I keep with Sentinel-2. In this case, I'm getting the maximum NDVI per month, 12 period. From, I'm going to put just 1 year. I'm going to put 2020 to 2022. Okay, and index NDVI. If I run this, so here you go. I'm going to clear again the rectangle. So here you go. This is beautiful. And you can tell now that the water is dark. It should be black because this is now a vegetation index, so water has low values, and low values gets black in the RGB composition. Not only water, also these are the sand dune of Doñana. Okay, this is the Guadalquivir, this is water pond, and you can see you have different color in the crops. You have here a very big blue area. This is because we put August in the third band, in the blue band. Okay, so here I'm watching in blue the NDVA of August, and this is rice field that gets the maximum value of NDVA at the end of the summer. That's why I'm watching this in blue. The thing that I watch in white is because are perennial vegetation, and for example these are pine trees in Guadalquivir river mouth in the summit pit of Doñana. So white means high values all the time in the index, in this case in the vegetation index. Okay, and this is kind of such approach to phenology. At least with us, just with a site, I could know which seasonality of this crop they have, and also I could get the same spectral profile that we did before. If I choose the plotting tool and I choose this map, if I click in one of them, okay, here you go. This is a summer crop with the higher values at the end of the summer. For example, if I want more data, okay, I can choose now, and I'm going to restart the map again, sorry. But sometimes it's fail if you are loading a lot of information. I prefer to restart, it's very quick. Let me find again my area. Okay, and now if I come back to here, now I can say that I want to split the year in 24 seasons, and now I can use the P1, P10, I don't know, whatever, P17, band name. The same for the same period, and the second, the NDVI, and the max. Just in this case, we are splitting the season in 24 periods, okay? Here you got, clear the rectangle, okay? And now if I go to the spectral profile with the plotting tool, if I click here in the right field, I would see something very similar to before, but now I have 24 data. So because I have 24 image, okay, and image means data in this case. If I click here, maybe I could go again, and I could say this is the vegetation in the marsh, the macrophytes on the marshland, okay, and this has the maximum in the springtime, okay. This is the spring. You can see the phenological curve of this area, okay. So let's keep moving. Okay, let's go to create a new map. Okay, and in this case, let's keep still at Doñana. Then we will move to other sites. But in this case, I just want to show you what I said in the presentation, that you can load all the statistics at just with one loop. Okay, so just with this small code that you run this. Okay, we have created a list with all the statistic name availables, and just entering in a loop, we declare the Ndvi seasonality, and we change the name of the statistics for the item inside the loop. Okay, so if I go now here, okay, I can watch in my raster, in my layer list, that I have the percentile 95, percentile 19, the mean, the median, and the maximum in DVI. Okay, if I keep all the layer on, and I use in this case the inspector tool, is the this information is I click on the map. Okay, we have just created the maximum value for the NDVI per month, the median, okay, the mean, the percentile 90 and the percentile 95. Okay, just for, in this case, just for the year 2020 and 2021. Okay, but I could use Landsat and create the last 40 years for that. You are watching how fast is this. I'm creating this different statistic of this index. Yeah, just like this, very, very fast. You can do that for any part of the world. What else? Also, I say that the last raster that is loaded on the map is the last raster is the one that is loaded on the map. But if you want to load all the raster on the map, you could do with this other loop that is here. Let me restart the map. Okay, if you run in local, it's not necessary to restart the map all the time, but here in Google Colab sometimes fails, so I prefer to restart the map. As I said, it's very, very quick. Okay, here I'm creating another list to go in a loop, and in this case the loop means the year. So I'm changing the year, and I'm going to load, in this case, just the maximum, or the percentile 90, the percentile 90 value for all the years. Okay, so here we go. I clear the rectangle, and if I go to my larger list, I have the I didn't change the name, but this is the percentile 90. So I have the percentile 90 NDVI for 2022 all along to 2018. Okay, so you can see that. Okay, and if I click on the map with the inspector value, okay, with the info, if I click anything, put on the map. Okay, so you will see I have the maximum, as I said, this is back with the name, it's a percentile 90. Okay. Okay, so you have the for the 2018, 2019, 2020, 2021 and 2022. Okay, for all the months. By the way, just by looking at the break of this NDVI, you can tell the effect on the severe drought that we have in Andalusia. You can see that the values are lower in the last year. Okay, so this was this loop. So this is a statistic that we are loading, percentile 90, but I mistaken, I left the name in the max NDVI, but the statistics is what percentile 90. If you want that this is correct, just change this to percentile 90 NDVI, or maybe you can change the key to max. It will be also very easy to combine these two loops, the loop of before with all the statistics, with this loop to load all the raster for all the years, and load all the statistics for all the year in the map. But I left that to you if you want to try. It's very easy to achieve. Anyway, this only load the last year in the map, but all the years are calculated. Okay, so in your variable of my class and the seasonality, it's all the years. Okay, so let's get moving. Okay, here I got an example. I want to show you this. I'm using in this line and connecting to another data set from Google Earth Engine. In this case, it's a vectorial with all the countries of the world. I selected all the countries in Africa because I want to display a gorgeous image of Africa, but this take a while. Yeah, a while is like, I don't know, you can try at home, but it's going to take like something between 5 and 10 minutes. It's very, very few time to compute all the Africa, in this case with Modis. It's a lot of pixels, but this video is already too long, so I'm not going to do. I left that for you, but I have here the image that you should get. Okay, at the end of the day, this is the biomes. Okay, you are watching the biomes, and as I said, it would be nice to split to do an analysis for a period of 5 years and compare how this is evolving during the time. Okay, but I would like to see. Okay, instead of use the Africa, let's go to use a ROI, just because it's very beautiful. Let's go to do a rectangle around the Delta Nile. Okay, this area is more or less the size of Spain. Okay, so this is a cute area anyway. So imagine the whole Africa. And we are going to do here, I need to say again that the ROI. Okay, let's go to copy this. Let's go to put a new code cell here, and I'm going to say that the ROI is again my drawn future. And now when I create my Ndvi seasonality, I'm going to say that the region of interest that I want is not country, but the ROI that I have just created. Okay, I'm going to create the mean, and I'm going to split the year in 4 periods, the season of the year, and 2020 to 2021 NDVI. Okay, so let's go. This should take no more than 1 minute. Okay, so here you go. Okay, you clear. As I say, this is very, very beautiful. Okay, in your local computer you could put this in the full screen, but it doesn't work in Google Colab. Okay, again, a lot of information here, not just the colors. Oh, sorry, I'm using, okay, I'm using Sentinel-2. Let me, okay, in collection, yeah, it's very easy to to make a mistake, because there's a lot of things that you have to change if you want to change something. The core resolution is because this is Modis. Okay, so we have to move to, because it was thought to make it for the full Africa continent, but let me restart the map. Again, I'm going to draw a rectangle around the Delta Nile, and I have to change. I'm going to define my ROI, and I'm going to change my satellite collection to Sentinel-2. Okay, and that's right. Now it's going to take a little bit more of time than before with Sentinel, but still pretty quick. Okay, let's go to clear the rectangle. Yeah, it's longer to render. Okay, here you go. This could be a nice picture for your for your salon. Okay, so again, as I said, not a lot of information here. Not just you can discriminate different types of vegetation just for the colors. Yeah, you know where are vegetation and when in the year you have the vegetation activity here. Okay, so also it's a very good tool to detect something that maybe you won't be able to detect just with an orthophoto. Okay, for example, here in the desert it's a lot of wall imagery. Okay, it's transparent. Okay, so I'm going to here, for example, maybe with the wall imagery you are not going to tell that there was anything here. Actually, in this zone you can see anything here, but now you can see that that's irrigation crops here. Actually, this resolution you can tell in the photos. Okay, and you can easily note that these crops are different than other this one, just because the different phenology during the time. Okay. Okay, so keep moving, and let's go to start a new map, and we're going to start. I say that we have Dane's bytes available from here, from Ndvi2Gif. So in this case, the only thing that we have to do is similar to PVP. You already watched this video. Is when you declare your ROI, your region of interest, you have to type Dane's ID. Okay. And then just paste the URL of your Dane's ID area. In this case, I'm taking, let me show you, Ireland dense. Okay, this is the Braille Island site in dense, so I have just to copy this. Okay, and if you want to use it, this is what you have to paste here. You can replace this for your dense site. Okay, and it will lead you to there. Okay, so it will be like that. So I'm selecting the Braille Island site with Sentinel-2, the statistics percentile 95, 12 periods per year from 2017 to 2022. Okay, and in this case I'm selecting the normalized different water index. Okay, and I'm going to run that on the map. Hopefully, if I go to Romania, it should appear the Braille Island. Okay, here it is. This is a water index, so I should be dark everything that is not water, and water, permanent water in white, very brightening. And I see also another colors. You can tell the blues here and the red. That means that this have the blue in this case, mean that this had water in this case in January, because it's the month, the composite that I'm loading has a blue channel in this image. Okay, so I actually I don't know anything about this area. I can see there's this river, and this seems to be some flooded area. This is January, so it could be true. But this is why it's important for us to have. We can apply this to the whole world, but we will need some validation data from your site to know where in Doñana we have this for Doñana, and we know when we have to put the cut between what is water and what is not water, because at the end of the day this is just an index from -1 to 1, but theory could be a good approach, but different sites will have a different cut for the point when you say this is water and this is not water. So maybe it's instead of 0, it's 0.05, for example, or something like that. So this is why it could be good to have validation data for your site for us. But this is something for the next video, eLTER map, the last video, hopefully. Okay, so we are watching the water here, and for example, it seems to be. Let me. I can add another imagery. Okay, just to see. Okay, so this thing that seems to be flooded, it's appeared it's true that this is our temporal flooded area. Okay, so it could be called red. Okay, so what can we do with that? Moreover, that we can use things ID as you already seen. We can, for example, I could create right now, if you understand it, I have a raster with 12 amp per year from 2017 to 2022. Okay, but if I want, I could say, for example, in an Excel, I could say January flood max, the maximum January flood. I could calculate this very easily. I take my image, okay, and I select January, okay, and if I comment this, if I comment the dot max at the end, with that I will be creating a new image, which in this case with 5 band, and any band is a January month from 2017 to 2022. Okay, but I can even more. I can go further and add the dot max here and at the end of this sentence, and with that, after calculating or creating this new raster with 1 band per January, per all the Januaries in this period, I'm creating a new composite. In this case, it's the maximum value that this water index reached in this 5 year in the month of January. So a lot of things that you could do. Okay, a lot of combination possible. If I apply this, I'm getting the maximum of the percentile 95. Okay, I could get the maximum of the maximum. I could get the minimum, the median of the maximum, for example. So all that you can imagine with the combining the statistics, you can apply. So if I run this, now I just to get a single band raster. In this case, the values are the maximum NDVA that any pixel have in this 5 year period. Okay, so if I run this, I should load a single band raster with the maximum NDVA of January. Okay, so you're watching this now. Okay, and for example, you have seen this of the dot max. What do you think that it's going to happen if I say when I add in the map to the layer, I can say, for example, here dot min. Okay, to the image with all the bands for all the year, I'm saying dot min. Okay, if I run this, okay, what I'm doing on the fly so quickly, I have created a new raster image. Let's go to check the values. But this I create a new raster image. In this case, it's not from a year. In this case, I have a raster band per month. But in this case, the value of this raster band per month is the mean of all the periods. Okay, so I have the mean values of the NDVI of January, the mean values of the last 5 years of February, of March, etc. In this case, bases on the percentile 95, the mean value of the percentile 95. Okay, so again, this is kind of amazing. I'm with Sentinel-2, but if I go with Landsat, I don't know, I can start, for example, in 2010. If I load this, okay, here you have it. This is the mean on the percentile 95 of the last 12 years of Landsat data per month. Okay, and this is what you get. Okay, I think it's a good approach to determine the flooded areas. Okay, so we are finishing right now. Let's go to create a new map. Okay, let's go to Doñana again. Let's go to do another rectangle. Okay, and here, well, I don't need the rectangle because I'm using the Danish ID of Doñana. Okay, so this is again with Landsat, 12 periods, the maximum value of the NDVI for the 2019. Oh, okay. So here you have it. This is the Doñana eLTER boundaries. Okay, also a very nice image. And what I want to say with this is that you can calculate zonal statistics with that. In this case, I put here one filter collection. This is come from my Google Earth Engine set, but you can use yours. Okay, it's called Alcornoques. The variable is oaks, trees. Okay, and I also have here this is for my local computer. You could easily here in, sorry, I have to move the screen again. Oh. Okay. Okay, if you open the folder, okay, you can upload data. So you can upload your own shapefile. But okay, I'm not going to do it. It is also very quick, but I'm not going to do it. You are going to believe me, and I will show you the result in QGIS. Okay, so with this in this cell, what we do is we are creating zonal statistics for this image that I have just created with the oaks on the first step, and then with the sample, just 10 random points in this area. Okay, you define the out file path. In this case, it's going to be created here in Google Earth Engine in Google Colab in your content. Okay, the statistics type and the scale. You can do resample in case you want to do a very big area. You could resample the pixel to get your statistic. Okay, but what this is going to do, this is going to create something like that. This is the 10 point that I say, the sample point, and if you open this point, okay, now you have the values of the NDVA for the year I was crossing. Okay, you can cross with a collection with a lot of year. This is just from one. Same from the oaks. Okay, if I go to the oaks, these are the polygon of the oaks. And if you open the attribute table, the same. You have all the NDVA values in this case for one season. Okay, you can also you can also download your collection. Okay, in this case I recommend that you download a small areas, because there's a limitation size for Google. Okay, you have to download small areas, and the only thing that you have to do to download it is my class get export. Okay, if I run this here, this is going to be okay. I'm going to do this. I'm going to draw a small area, so I want that this be fast. Yeah, maybe a small area like that. I define a row. Okay, I'm going to create my new collection. Okay, so it's this raster, small size, and if you want to download, you can download more than that, but I want to be fast, so I only have to do my class get export. Okay, and you will see that this is going to be storing your content in Google Colab. Okay, here it is, the first one, and you only have to click here and download. Okay, very similar to the data that if you do local, it's going to be stored in your current environment. Okay. Okay, so that's all. Well, just to end, another image that I like it a lot. For example, as I said, we more than vegetation and water, we added a couple of things to work with burned areas and with snow. Okay, so we could go here to Sierra Nevada. I could draw a rectangle. By the way, I draw a rectangle because the Danes ID of Sierra Nevada is not working, so maybe someone can check that out and try to solve it. So I define my row. Okay, and in this case what I'm doing, I'm going to create with Sentinel-2, I'm going to select the normalized different snow index from 2020 to 2022. If I run this, okay, I have this beautiful image, and as you can imagine, the brighted means always snow or more time snow. Okay, and the other colors mean snow in some one of the years. But as we did before, if we want, we can, for example, change the collection to Landsat. Okay, we can keep the median as statistics, and we can go all I go to 2010, and I can say again the mean. So I'm going to be the mean. I would say the mean extension of the snow in the last 12 years. Okay, just by running this, and if everything goes well. So here you got, okay, the mean extent of the snow cover in Sierra Nevada in the last 12 years. Okay, so that's all. Sorry for this long video. I don't know if anyone is going to watch this till the end. If someone does, please write me an email. I will send you something. Cash present. Okay, so see you in the next and hopefully last video about eLTER. So see you all. Have fun. Bye.